Good evening.
Good good morning to you. No, or is it already evening in your?
It's the afternoon.
Okay, so yeah,
Yeah,
so
so I'm
well, yeah,
skipping
good
lunch to
afternoon.
be here with you guys. It's okay.
Yeah, sorry to sorry for the bad timing. So yeah, so Thomas is with the GM, General Motors, and he'll be telling us about sulfide glass solid state electrolyte separators for semi-solid lithium sulfide batteries. So you have 18 to 20 minutes for the presentation, and then we go into Q&A. So good luck to you.
Yeah, sounds good. Thanks for joining, and I hope I can share some technology that will be of interest to the group. So my name is Tom Yersak. I'm a senior researcher at General Motors R&D. In North America, I lead our research efforts in solid state. And then when I was a graduate student, I worked on a DARPA project, which eventually got spun out into solid power. So I was very grateful to have contributed to that work. So today, what we're going to share is our cell design for a lithium sulfur battery that incorporates a sulfidic solid state electrolyte separator. So it combines both a solid state electrolyte and a liquid electrolyte, and that's why we call it semi-solid. All right, advance the slide. Okay, so I'm going to start kind of like with an introduction of what my organization is all about, and then provide some background into why semi-solid cell design would be of interest to GM. And then after that introduction and background, we'll dive into some of the materials development work that we did to enable such a cell design. And then I'll show how we took the materials we developed and actually implemented the cell. So let's start with the intro. So as I said, I'm from General Motors Research and Development. We've been around since 1920. I haven't myself, but we're located in our technical center in suburban Detroit, specifically Warren, Michigan. And within our organization, there's a bunch of different groups. So in addition to GM Ventures, there's 6 different labs, and I'm in the Battery Cell Systems Research Lab. So a majority of our time is spent supporting our engineering colleagues in product development, but we also have the opportunity to operate a lot like a national lab in the United States, wherein we can apply for funding and use that to support high risk but high reward research. So the work that I'm going to present today was supported by the DOE's Battery Material Research Program. Okay. And that work focuses on the design of solid state batteries with a lithium metal anode. So we're going to shift a little bit of focus from some of the silicon talks that I think are bookending me. So anyways, why are all solid state batteries, why is that design so difficult? And it has to do with creating and maintaining interfaces. So batteries are an electrochemical device, and electrochemistry happens at interfaces. So it's a critical feature that we have to consider. So in a conventional lithium-ion battery, we have a great interface because the liquid electrolyte can wet the electrode, and that's what I'm showing here on the left. Now, in a solid-state battery, where the solid-state electrolyte is now a solid phase, that interface, that electrochemical interface, is limited to points of solid-solid contact. So it's difficult to make. And then it's also difficult to maintain because as we cycle the cell, the electrodes will swell and contract every time we charge and discharge. And so that figure on the right, not my own work, basically shows that the interface between these two materials degrades as the cells are cycled. And so as a result, to overcome these issues, solid-state batteries oftentimes will require more stringent operating specifications than a conventional lithium-ion battery. And the things that we're concerned about, when I say we're, my colleagues in the engineering module team, is like what temperature is required. So the solid-state batteries might require an elevated temperature, they might require a higher face pressure, and they may require a slower C rate. And the C rate is a measure of how fast the cell needs to charge and discharge. So we can shift gears to a semi-solid design to alleviate a lot of these issues. I'm going to conclude this presentation with the cell technology shown here on the right. But basically, what it is a conventional lithium sulfur cell where we drop in a replacement separator component